Hello YouTube, this is my fifth video on my module on logarithmic functions. In this one we're going to focus on just the transformations of the general graph of the parent function in this one. So we say a more general form. Let's go ahead and take a look at what we have here. A more general form of our parent logarithmic function. Recall that the parent function is just y equals log base a of x is this. Y equals log base a of x minus h plus k. Okay. But we say, just like with many other functions, h here is always involved in parentheses with x. If there's no h apparent, we'll just say it's 0. But basically, h is responsible for horizontal shift and is dishonest. I say, not that it's so much dishonest as much as the fact that it's just that it has a negative inside here. So it looks, if it says minus 3, it actually shifts 3 to the right. If it says like plus 4, it actually shifts 4 to the left. So it's not dishonest, it just has a negative in there. And also k is responsible for vertical shift and is honest. Okay. One thing I do want to point out is this. We say, what do we already know about the graph of y equals log base a of x in general? Okay, so in certain sense, we say we know a few things about the parent function right off the bat that we should have memorized. We should have memorized, first of all, the fact that it has a vertical asymptote at x equals 0. We should know that it goes through the point 1 comma 0. So it has this for an intercept. Whoops. Let's write it down here anyways. We say 1 comma 0. We should know this. Everybody should know this. And then we say it goes to the point a comma 1. So we say, it's like a comma 1. This is very true about all logarithmic functions. All I'm saying now is essentially this. We're going to be shifting these left and right, up and down, and possibly reflecting, about our y-axis or reflecting about the x-axis, depending upon, if I throw in a negative in front of my x, it will reflect over the y. If I throw in a negative about my y, it'll actually reflect about my x. And we'll get to that when we get to it. But for right now, one thing I do want to point out is this. If I said this is y equals log base a of x minus h, the fact is this. We have an asymptote at x equals 0. Okay, but h is responsible for horizontal shift, and recall that we're going to shift, h units left and right. So if I were to shift h units to the left of 0, I'd be at negative h. If I were to shift h units to the right of 0, I'd be at positive h. So I guess what I want to say is this. We say there's a vertical asymptote, okay, of a logarithmic function before we kind of continue is this. We say is always at x equals h. And the reason why is because if originally on the parent function it's always at x equals 0, well, however many units we shift left or right, the asymptote shifts with it. So, as an example, if I were to graph y equals log base 2 of, x plus 2, I suppose we could go ahead and do this. We say, originally the parent function would be log base 2 of x, except we would be shifting 2 to the left. So 2 left on this one. What I would say is then instead of this function here that we've got sketched, we'd say we'd go left 2 with everything here, including the asymptote. This is what I wanted to point out. The asymptote would be x equals negative 2, which is essentially the h value here is negative 2. Okay, I know it looks like positive 2, but it's negative 2. Instead of going through 1, 0, we'd click back twice. We'd say now it'd be at negative 1, 0. And instead of, in this case, 2 comma 1, which is where it would be on log base 2, it would be at 0 comma 1, and then this would be our slowly growing logarithmic graph. Well, anyways, I would like to graph a couple of these and then be done with this video, but we say, all right, use the graph of the parent function to sketch the following transformations. Be sure to label the asymptote of the graph as well as any points on the graph. Okay, so it's very important. If I were asked to graph y equals log of x plus 4, now this is log base what? It's a common log, so we say log base 10. Then really what I'd be doing is this. I'm going to go ahead and graph this as if it was just log of x, log base 10 of x. Know what I know about that, and then shift everything. So first thing I'm sketching in is just like every common parent function here. We say has an asymptote at x equals 0. Goes to the point 0 or 1, 0, excuse me. Since this is log base 10, if I were to plug in an x value of 10, right, log base 10 of 10 is 1. So if I'm out here an x value of 10, I'd be at a height of 1. Okay, so I know that my original parent function looks like this. So we'll switch over to a different color. But in this case, you'll notice that I have an h value of negative 4 actually. It looks like positive 4, it's negative 4. So we say h is negative 4. So let's go ahead and shift everything that we want to shift here, starting with the asymptote. Since I'm shifting left 4, instead of x equals 0, it'll be at x equals negative 4. So 1, 2, 3, 4. I've now got a vertical asymptote that shows up at x equals negative 4 because it's been shifted from my parent function left 4. instead of being at the point 1, 0, which was on the original, shifting left 4, 1, 2, 3, 4, it'll be at the point negative 3, 0. And then now, I mean, I should label this negative 3, 0. And instead of being at the point 10, 1, I should now be left 3 from there. So, or left 4, 1, 2, 3, 4. So I'll be at the point 6, 1. So this isn't bad. I mean, this is all that's really going on here, is we're just taking the original parent function, and because the h value is negative 4, we shifted to left 4. Likewise, on this other graph over here, you notice we have a k value, and k is honest. But let's take a look at this. If I were asked to graph this, again, I would graph just plain old log base 3 of x first, the parent function, and then we'll shift it from there. So what do we know about the parent function of a logarithmic thing? Well, it has an asymptote, okay? It has an asymptote that is the y-axis at x equals 0. If you haven't memorized this yet, I don't know why you haven't, but x equals 0, we go through the point 1, 0. This is on every parent function of a logarithmic thing. And we say, in this case, since the base is 3, if I were to take log base 3 of an x value of 3, I would get a y value of 1, because 3 to the power of 1 would be 3. So over 3 up 1. This is on our graph. So it doesn't grow as slow as our log base 10 function, but it still grows slowly, so we want to not have that take off. And what I mean by that is I have students sometimes draw their logs like this, and I'm like, you're crazy right here. Crazy. I'm just saying. So anyways, let's go ahead and take a look at what this new graph would look like, starting with this. First of all, there is no h value. No h, which means we didn't shift left or right at all, so it still has an asymptote that is on the y-axis. So it still has the asymptote x equals 0. Now it shifted up twice, so instead of the point 1, 0, it should be at 1, 1, 2, 1, 2, 1, 2. And I shouldn't put that right there because I'm about to shift 3, 1 up twice to 3, 3. And so we'd say 1, 2, labeling my graph points just like I asked. We say 3, 3. This is our new graph here. And it grows slowly. Logarithmic things grow very, very slowly. So this is what the graph would look like, okay? So as an aside, I would like to look at one more thing. You can turn the video off right now, but reflections. What if I had a reflection, okay? So what if, for instance, I said let's graph y equals negative log base 2 of x plus 1 minus 3. Oh my goodness, there's a lot going on here, okay? So let's start with this. We're going to actually do our reflection first, okay? So what I want you to notice first of all is this. If I were to graph this, the first thing I would do is graph log base 2 of x. Graph the parent function. Just graph the parent function. We'll do all the transformations next. So as far as the parent function goes, again, it has a vertical asymptote at x equals 0. It goes through the point 1, 0. In this case, since it's log base 2, we say, well, let's plug in 2 for x because we'd get 1 to the 1 equals 2. So we say 2, 1 would be on this graph. All right, so basically I've got the entire parent function right here. How would this be different? Okay, so we say since I put a negative out in front here, not in front of my x, okay, I negated y. So if I negate y, I'm reflecting about the x-axis. So if I reflect everything over the x-axis now, what I end up with is this. We'd say I'd still have this vertical asymptote on my parent function here. I'm going to switch over to like a, I don't know, I like an orange on this one, orangey, okay. The point 1, 0, if you reflect this about your x-axis right here, would still be at 1, 0. If you reflected this point, which is 2, 1, about the x-axis, it'd be at 2, -1. So it'd be down here. So we'd say my parent function, all I've done is I've reflected it over my x-axis. So now we're going to apply some shifts. So we'd say this would be left 1, down, oh no, down 3. So we're going to apply this shift. We're going to start with the left 1, okay? Since my asymptote was at x equals 0 before, we'll go left 1, and now I've got a vertical asymptote at x equals -1. I am going to ask people to label that, okay? We're going to say left 1, down 3. So let's grab our point here on the orange graph that we reflected. It was at 1, 0. If I go left 1, down 3, so now I have that point here. So this point went left 1, down 3. Let's grab that and label it. So we'd say that'd be the point 0, -3 here. And then also, we'd say this point here, which was at 2, -1, we need to shift it left 1, down 3, 2, 3. So now it's at 1, -4. You're going to have to think about that and figure that out. But basically, it is a graph that, simply put, it just got reflected about the x-axis, shifted left 1 and down 3. So all the transformations you've probably seen on every other function, they apply here. Just, draw the parent function first and then shift where you need to be.